Hello, this is a video looking at the parallel circuits worksheet. And again, quick reminder, in the last one we did series circuits, where series circuits, that's when the resistors are one after another, all in the same line. In parallel circuits, remember, that's when they split up. So you have come up here, and we have what's called a junction, which I'll make this red dot. And then the current splits into two or three or four different spots. And then eventually, so we could go through resistor here, and then they come back together at another junction, and then turn on their way. So parallel circuits, you have to have this junction where it splits apart. And again, the key one's off of the parallel junction. Since they are in parallel and they connect the same 2 points, V total has to equal V1, which has to equal V2, which has to equal V3, so on and so forth. That's the potential difference. The voltage drop across. The currents add up, so I total has to equal I1 plus I2 plus I3. And then our resistances, this is the weird one, and that's because in its essence, every time you add a resistor in parallel, you're increasing the area. 1 over the total resistance, or equivalent resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth. So those are the equations that are on your reference table. So let's go ahead and take a look at these. So in the first one, we have a 4 ohm and 6 ohm resistor hooked up in parallel to a 10 volt source. So we know that R1 is going to be 4 ohms. R2 is going to be 6 ohms, and V total, that's the voltage of the circuit, is going to be 10 volts. We want to know what is the total resistance. So for this, I'm going to use the 1 over R total, or in your reference tables, it's known as REQ, the equivalent resistance, is equal to 1 over R1 plus 1 over R2. Now on your calculator, you're going to write this as it'll be R total to the negative 1 is equal to R1 to the negative 1 plus R2 to the negative 1. And if you're not sure where this is in your calculator, stop in, see me, and I will show you exactly where this is. But what you're going to do is you're going to go, and I'll go back to the old school way, 1 over 4 ohms plus 1 over 6 ohms, and that's going to equal 1 over R total. And so when I get that, R total is going to become then 2.4 ohms. Then in part B, what's the total current? Okay, the same rules apply as in series. If we want to have I total, I have to have subscripts all be the same. So I'm going to use Ohm's law, but I have to use V total and R total in this case. So my V total, that's 10 volts. R total, that's at 2.4 ohms. And so when I get that, I'm going to get 4.17 amps. And I think it's 4.1666666 going on and so forth. So I rounded to 4.17. Then they want to know what the voltage drop across the 6 ohm resistor. Now this one's actually really easy because the total voltage has to equal V1, which has to equal V2. So my total voltage across the parallel has to equal the voltage drop across the individuals. So that's just going to be 10 volts. And if they want to know the current flowing through the 4 ohm resistor, I'll put this one in the blue. So there's my blue. So I of the 4 ohm, I'm going to have to use the voltage across the 4 ohm divided by the resistance of the 4 ohm. And this is where it's really, really crucial. Make sure you have the same subscripts. Now, because the voltage is all the same, that's easy. So that's 10 volts. And my resistance of the 4 ohm resistor is, in fact, 4 ohms. So that'll give me 2.5 amps. Okay. If we take a look at the next one, now we have 3 resistors. So R1 is 20 ohms. R2 is equal to 5 ohms, and R3 is equal to 50 ohms, and they do have our V total to be 100 volts. So again, we want to find the total resistance, so I'm going to use 1 over R total, or REQ, is 1 over R1 plus 1 over R2 plus 1 over R3, and so I'm going to go 1 over 20 ohms plus 1 over 5 ohms plus 1 over 50 ohms. Okay, and if you don't want to use a calculator, here you would have to use a common denominator. Common denominator in this case is going to be 100. So you could actually do it. Oh, for fun, I'll do it. Why not? So this would be 5 100ths plus 20 over 100 plus 2 over 100, and so that's going to give me a grand total of 27 over 100 is equal to 1 over R total. So R total would equal 100 divided by 27. So when I do all that out, that's going to give me actually 3.7 ohms. Okay. Part B, what's the total current flowing through the circuit? So in this case, I want to find total current. So I'm going to have to use V total and R total. So V total, that's my 100 volts. My R total, we just said, was 3.7 ohms. I apologize, I'm sweating, just got out of the shower. So after a lift, had to get a lift in this morning. So 100 over 3.7, and so that's going to give me 27 amps. Okay, you may have rounded that. I might have rounded that just a touch, but it was because it wasn't exactly 3.7. But it's going to give me very close to 27 amps. Voltage drop across each resistor. Again, that one's easy because V total equals V1 equals V2 equals V3. So in this case, it's all going to be 100 volts. And lastly, what is the current in through each resistor? So if I want to find the current in the 20 ohm, I'm going to use the voltage across the 20 over the resistance of the 20. So that's 100 volts divided by the 20 ohms, which gives me 5 amps. The current in the 5 ohm will be the voltage across the 5 over the resistance of the 5. So again, 100 volts because it's in parallel over the 5 ohms, which will give me 20 amps. And then the current across the 50 ohm will equal the voltage across the 50 divided by the resistance of the 50, which will be 100 volts all over the 50 ohms. This will give me 2 amps. Now conveniently, if I look at these, I'll highlight this, 5 plus 20 plus 2 does give me my 27 amps, which is kind of what we thought it was before. So nice to have confirmation there. All right, and our last one. 2 identical resistors are hooked in parallel and have a combined resistance of 40 ohms. What's the individual resistance of those resistors? So we know our total, or REQ, is going to be 40 ohms. And I'm going to draw a picture of this, that it comes up and it splits, and we have one resistor and another resistor. Bing, bing. And then they come back together. So I know they're in parallel. So R1 and R2 are there. But because they're identical, I can just say, instead of R1 and R2, I'm just going to say, call it R and R. So I know that since they're in parallel, 1 over R total is equal to 1 over R1 plus 1 over R2, or in this case, 1 over R plus 1 over R. So 1 over 40 ohms will equal 2 over R, because 1 over R plus 1 over R will give us 2 over R. And so now when I cross multiply this, that tells me that my R is 80 ohms. Okay, and this one's a little bit tricky, but again, you have to think your way around a corner on this one. So I hope this helped, and if you have any questions, again, if you're not sure on these, try some of the should-dos, and I'll give you the answer key to those as well. So all right, take care and have a great day.